Alright guys, so today we're going to be studying sequences, and this is an introduction to sequences. And what sequences are simply a list of numbers. And that list of numbers usually follow a pattern. For example, we're going to start with arithmetic sequences. Okay? Alright, so arithmetic sequences follow a pattern as well. And you're going to tell me what it is in a second. If I start with 5, and then I'm going to write 8. Okay, so think about the numbers. I kind of figured out what's happening. So we got 5, 8. All right. And I have 11. Then I'm going to have 14. Then 17. Then 20. Could you tell me what is happening and give me this number there? All right. So if you answered 23, that is correct. What is it that I'm doing then? Well, I'm adding 3 all the time. So an arithmetic sequence is a list of numbers where you're adding or subtracting a fixed number. Okay, let me say that again a different way. So arithmetic So for arithmetic sequences, you add, or you could even subtract a number and we call this as a fixed number. Now that fixed number has a name. We call it the common difference. And hopefully you're writing this down. The common difference is the number that gets added or subtracted. All right. We'll see a couple more examples of an arithmetic sequence. Now, geometric sequence, let's talk about that. A geometric sequence, let me give you an example and then you can kind of tell me what is happening. I'm going to start with the number 1 and then I'm going to do 2. Now let's do 4. Now 8. Now 16. Now 32. Could you tell me what the next number is going to be? What is happening in this sequence? If you guess 64, you are correct. So what's happening in this one is instead of adding or subtracting a number, we're actually multiplying by a number. In this case, we're multiplying times 2. So could you tell me what the next number will be? Alright, if you guess 128, you are correct. Alright. Alright, so now this number right here, okay, so a geometric sequence, let me go back a little. It's going to be a list of numbers that is being multiplied by a fixed, or being divided by a fixed number. So geometric sequence, I don't know what I put here, deal with multiplication or division, just to put it in very simple terms. And then the number that gets multiplied by, or the number that we're multiplying by, is called the ratio. The ratio is the number, or the fixed number, you multiply or divide by in the sequence. Okay? Now, are all sequences going to be arithmetic? Are all sequences going to be geometric? Not necessarily. Okay, there are a few sequences that are neither. Let me give you an example of a sequence that is neither. For example, I'm going to do 1, and then I'm going to do another one, and then I'm going to do a 2, and then I'm going to do a 3, then 5, then 8, then 13, and so on and so forth. What do you think is happening in this sequence? There is a pattern that we're doing. The pattern is the following. We add those two to get that. Then we add those two to get that. Then we add those two to get that. So could you give me the next number there? When I add those two, what is the next number in the sequence? Alright, if you answered 21, you are correct. This will be a neither sequence. Why? Because even though there is a pattern that we follow, it's neither arithmetic. We're not really adding any fixed number. So yes, I am adding this and I'm adding that, but you have to add a fixed number all the time. There needs to be a common difference. Okay? So this would be a neither one. How about if I give you this? 1, 4, 9, 16, 25, 36. Could you give me the next one there? Well, this one will be a neither one. The pattern is probably not that obvious when you look at it and when you look at the numbers, but when you look at the numbers, you can see that they're all perfect squares. 1 square, 2 square, 3 square, 4 square, 5 square, 6 square. What will be the next one then? If you answer 49, you are correct. So, you know, that's a little introduction of sequences. We have arithmetic sequences, we have geometric sequences, but we could also have sequences that are neither of those. All right. Let's take a look at this question here. For each arithmetic sequence, so we talked about arithmetic sequences already. We know that arithmetic sequences, we add or subtract a number. We're going to find the common difference. What is the common difference? Well, the common difference is the number that we're adding or subtracting all the time. And then they're asking us to find the new two terms. All right, so what's going on here? What are we adding constantly? It seems that we are adding 3. So the next term, the next two terms will be, well, 13, 16. We add 3 more. We get to 19. And then we add 3 again. And then we get to 22. On this one here, we're actually seems that we're subtracting 5. So remember, arithmetic sequences, you could also subtract 5. So we got 25, and what will be the next one there? That would be 20. All right. Now the common difference on this one here, which I'm going to write as D. So the common difference is usually denoted as D. It's going to be 3. The common difference in this one, which is denoted as D as well, will be -5. Okay, because on the second one we're subtracting 5, on the first one we're adding 3 constantly, and that is a arithmetic sequence. Now for each geometric sequence, so geometric, remember, we're multiplying or dividing by something. Usually we can always say we're always multiplying by something. It says find the common ratio. Okay, the common ratio, remember, is that number that we're multiplying by constantly. And then we got to find the new two terms. All right, so we're multiplying by something here. Can we figure out what it is? I believe, well, 2 times what is going to be 6, I'm sorry. Well, 2 times 3 will be 6. So could you give me the next two? All right, so that first term will be 54 times 3 will give me 162. And then 162 times 3 will be 486. Now, can we tell what's happening in here? How do we find the common difference, guys? Well, it's not that, I'm sorry, not common difference, common ratio. How do we find the common ratio? You can usually take the second number, -40, and divide it by the first number. That's going to give you a ratio. Now, if we simplify by, we're going to get, well, divide by 20 on both sides, and we'll get negative, and actually divide by 40, and you get -1.5. So in reality, we're multiplying times -1/2 on both every time. So the next one here, if we multiply times -1/2, if we multiply that -10 by -1/2, what do we get? We'll get 5. And then in this one, we're actually going to get a fraction, which is going to be -5/2. Okay, so the common ratio will be -1/2. To find the common ratio on this one, we could also do 6 divided by 2, and we will get 3. But I think for C, it's a lot more obvious than for D. All right, let's take a look at the next stuff here. Use the given formula for the n term. Find T1, T2, T3, and T4. Then tell whether the sequence is arithmetic, geometric, or neither. Okay, so what is this whole thing of T1 and T2 and T whatever? Well, how do you find T1? Let me just show you an example. You're going to see that this is very simple. So T1, how do we find T of 1? Well, all we have to do is replace that n with a 1. So kind of like substituting. All right, so 4 times 1 is 4 plus 5. Well, that would be 9. How about T of 2? Well, 4 times 2 is 8. Okay. And then plus 5 is going to be 13. How about the next one? T of 3. Well, 5 plus 4 times 3. 4 times 3 is 12 plus 5. It's going to be 19. actually, I'm sorry, 17. All right, so now that we have the first three numbers, what are we adding constantly? Okay, from 9 to 13, what are we adding constantly, or what is happening? Is it arithmetic, is it geometric, or is it neither? Well, I can see that we're actually adding 4 every single time. So we have to find the next one there, t of 4, what would that be? Without even doing the problem. When you add 4, you should get 21. And that should match with this as well. 4 times 4 is 16, and 16 plus 5 is definitely 21. Since we're adding 4 constantly all the time, okay, then since we're adding 4 constantly every time, then this is arithmetic. Okay, this would be an arithmetic sequence. Okay, and that's how we find those there. All right. Now, something that you can tell that this is definitely arithmetic, the reason why you can tell that it's very arithmetic is because we have a 4 right there. That right there looks at the slope. The slope is another way we can say the common difference. So we could actually graph this if we wanted to. All right, let's try B, n squared. All right, so we're gonna start with t of 1 will be 1 squared, which is 1. T of 2 will be 2 squared, which is 4. T of 3 will be 3 squared, which is 9. And T of 4 will be 4 squared, which is 16. Now, is this geometric? This is arithmetic. Okay, so if I try to do arithmetic, well, I add 3 right there. But then from 4 to 9, we're adding a lot more than that. We're definitely not adding 3 again. Remember, there has to be a common difference. Okay, it can't just be add 3 and then add something else and then add something else. It has to be the same number that we're adding constantly. So in here, 4 plus, something, it's not going to give, it's 4 plus 5. Okay, it's going to give you 9, but that's not what we want. We want those two numbers to be the same. So we know it's not arithmetic. Okay, if we were trying to find out if this was geometric, then we will have to multiply times 4 there. Well, 1 times 4 will be 4. But then, are we multiplying times 4 again to get 9? Not at all. It's not geometric either. It's not arithmetic, so this would be one that we call neither. And I think this was one of the examples that I gave you guys already. All right. How about C? Let's give that one a try. So write this one down. We have t of 1. We're just going to replace that n with a 1. So 2 to the first power, well, that would be 2. And 3 times 2 will be 6. Let's try t to the second now. It will be 3 times 2 to the second. Well, 2 to the second is 4, and 3 times 4 is 12. Let's keep going, guys. T to the third will be 3 times 2 to the third. We know that 2 to the third is 8. And 3 times 8 is 24. Could we see a pattern already? Let's see if we can. All right, from 6 to 12, we could say, oh, what if we're adding 6? Are we adding 6 right there? No, we are not. So this is not arithmetic. How about geometric? Are we multiplying by something? Well, to go from 6 to 12, I will have to multiply times 2. Then, am I multiplying times 2 here as well? Well, yes, we are. 12 times 2 will be 24. Now, let's see if we could predict the next number then. I'm going to predict that 24 times 2 will give me 48. And let's see if that actually happens. So t to the 4 will be 2 to the 4 there. It will be 3 times 16. And then if I grab my calculator, 3 times 16 will definitely be 48. So could we predict what t to the 5th is? Yes, very easily. What would that be? That would be 96. Okay? And of course, we forgot to say that this is a geometric sequence. All right, let's do a couple more examples and then we'll be done with this lesson. It says here, find the next two terms. All right, so let's see what's happening in here. What is going on in here? Are we adding something? What are we adding? It seems to me that the common difference in this will be, well, 2 plus 4 will be 6. And then the difference between 6 and 12, well, that will be 6. Are we multiplying? Is it times 3? But 6 times 3 is not 12. So we can see that it's not geometric. Then it's not arithmetic either because we're not adding the same number. But could we see a pattern in here? 12 plus what is going to give 20? That would be 8. Then 20 plus 10 will be 30. Could you see the pattern in here? If you can, tell me what the next number will be. It seems that there is a pattern within the numbers that we're adding. So we're adding 4 plus 6, then 8, then we added 10. The next number that we could predict is 12. So the next number will actually be 42. Well, now that you know that, let's see if you can find the next number. That will be 54. Because we're adding, actually did it wrong. It's now 54. We're adding 14 now. I added 12 for some reason. We got 42 plus 14. It's 56 actually. So that will be the next two terms. So sometimes the pattern is not clearly visible. We have to find a pattern. And finding the pattern is sometimes a little bit difficult to do. Let's see if we can find a pattern for the next ones here. All right, are we adding? Are we subtracting? What is happening in here? Well, it seems to me, well, let's try it. Are we adding 2.5? Is that what we're doing? Okay, 4.5 plus 2.5, that'll be 7. Is this geometric? Because if we subtract 4.5 minus 2, I know that I get 2.5, right? So, but it doesn't seem that we're adding 5, that we're not adding 2.5 constantly. So what is happening in here? Is it a common ratio? Are we multiplying times something? Is 4.5 divided by 2? Is it 2.25? Is there a pattern here? So we got 2.25, that's the ratio. Are we multiplying 4.5 and then we're getting, are we multiplying 4.5 times 2.25? Okay, there doesn't seem to be an obvious pattern in here. Okay, not an obvious pattern. In here, I added 2.25. I'm sorry, 2.5. And then what did I add in here? So 6 minus 4.5 is 1.5. And then it seems that I added 1.5 here. Okay, that's what it seems like. So this might have been a mistake. This might have been 3. Okay, and that would have made it 1 point. If it was 1.5, it seems like we're constantly adding 1.5. But in this pattern, the first term that we added was 2.5. Then we added 1.5 and again 1.5. So we could predict that the next one will also be 1.5 added. So 7.5 plus 1.5 will be 9. Okay, could we say for sure that this is arithmetic? Not really, because the first one that we added was 2.5. Now that might have been a mistake, but we can't really say that this is arithmetic. But we could say that we're adding 1.5 after that, and that is the sequence. How about this one here? What is going on in here? We went from square root of 6 to 6, and then from 6 to the square root of 6. What would the next number be then? How do we get 6? Well, if I take this number, because I feel like this is a geometric series, if I take this number and I divide it by the square root of 6, what would I get? Well, let's see if I could simplify this by multiplying times the square root of 6 there. What will happen in here is that the square root of 6 times the square root of 6, we're just going to get 6 there. And on top, we're going to get 6 square root of 6. This cancels out, and we get square root of 6. So are we multiplying times the square root of 6 all the time? It seems like we are, because 6 times the square root of 6 will definitely give you that. So what is 6 square root of 6 times the square root of 6? If you answer 32, you are correct. Why? Because 6, square root of 6 and the square root of 6 is actually 6. And 6 times 6 is 36. I don't know why I put 32 there. Alright, so the next number here will be 36. Alright. Alright guys, so I'll leave the video up to that point, and then I'll give you guys some homework after that. Make sure that you reach out to me if you guys have questions, and I'll see you guys on the next video.